So in part one of this lesson, we ended by saying that the right temporal parietal junction may be involved in encoding someone else's thoughts, right? Especially if they're different from our own. So the right TPJ, along with some other areas of the brain, are involved in what we're calling this mentalizing system, giving us a capacity to think about other people's thoughts, beliefs, desires, intentions. So let's take a look at a couple other types of fMRI studies, and that'll give you a sense of the diversity of stimuli used, but they all show activity in right TPJ. Well, we've seen the false belief contrasted with false photograph. Remember, the contrast would be this is the brain activity that we're going to subtract from the target task activity. Stories featuring mental states of characters contrasted with stories featuring physical descriptions. Again, activates right TPJ. If you say, well, how likely is Queen Elizabeth to think that keeping a diary is important, and contrast that with how likely is she to sneeze when a cat is nearby, again, right TPJ activity. Would Christopher Columbus know the object's function? So the subjects just see an object, and then they're asked this question about Christopher Columbus, contrasted with they see the object and they describe the object. Again, the figuring out whether Christopher Columbus would know what the object's function is activates TPJ. If you just see sentences like, he thinks that the nuts are rancid, and contrast it with, it is likely that the nuts are rancid, again, that contrast shows activity TPJ. Or if you judge how happy a person was to be photographed, so they see pictures of people, judge how happy they were to be photographed compared to judging how symmetrical is their face. Again, the contrast shows TPJ. What if you match the mental emotional state of photographs showing only the eyes and then subtract a judgment about gender, you get TPJ. Now, what is this task? Well, here's like a picture of eyes, and the task would be to pick the appropriate word that matches the eyes. So we have to do some mentalizing here. What is this person? What's their mental state? What are they feeling? What's their emotional state? That task, contrasted with just what's the gender of the person, activates TPJ. If the subjects are watching two kinds of interactions, one intentional harm contrasted with accidental harm, then you get, again, TPJ activity. If they're told to read a story and then decide if a word was in the story, and the stories can have false belief statements or just statements about physical events, so that would be the contrast. Interestingly, even though they're not even really focusing on the nature of these statements, they're just kind of doing a word detection task. Even when they're not, the attention is not directed at mental states, the theory of mind system is activated, so you'll get TPJ activity. If people in the fMRI scanner are watching a person doing an action, so they're watching a video of a person doing something, and as the scanning goes on, you ask them, why are they doing it? And then in a different block of trials, you ask them, what are they doing? And in a different block of trials, you say, how are they doing it? You get progressively less activity in the mentalizing regions, right? So if you ask somebody why somebody's doing it, well, then that's going to force us to think about their mental states, their desires, their goals, their intentions, etc. But as we go to the what and then the how, we're doing less mentalizing. Now here's one final contrast I wanted to share, and we'll call this the social animations versus random animations. And I'll show you some video clips of this in class, but the idea is there's a little scene going to play out here between some shapes here, a circle, a triangle, small triangle, big triangle. And when these objects move in certain ways, it is just very easy to interpret it as a social interaction, that these geometric figures actually have goals and intentions and emotions, etc. So you can make these things kind of move to make a little social scene, and the fact that people kind of report that they sort of interpret it as these are social agents with mental states, well, that led researchers to wonder, well, what's going on in the brain? So a nice contrast then would be to have the social animation film and then contrast it with where the objects are just kind of randomly moving around. So no evidence of any kind of social interaction, but still you get motion of these objects, but just in a random way. And when you do that contrast, you see theory of mind activity in right TPJ. So here's the right hemisphere, And the blue dots would be traditional theory of mind tasks. So there's the activation there. But notice the social animations contrasted with random animations. You get activity that closely overlaps what traditional tasks do. So this supports the idea that when we're watching little shapes move around and we're having that kind of feeling that they are agents with mental states, well, our brain is showing activity in precisely those areas that are involved in mentalizing. Biological motion stimuli, people walking, jumping, or running, or whatever, are shown here in yellow. So there's a region here involved in sort of social perception. So there are social agents moving around, and if we're computing their mental states, then right TPJ gets activated. And it's interesting to note that there are individual differences. So for example, on the social animation task, during these social animations, the theory of mind-brain activity was correlated to the use of mentalistic terms, right? So some people, when they watch it, they just kind of, they generate more terms to describe what was going on. And other folks don't. And so greater activity in the theory of mind regions, like right TPJ, was associated with greater use of mentalistic terms when they watch these social animations. So if we think about these set of fMRI studies, there's a wide variety of stimuli: complex narratives, simple sentences, nonverbal cartoons, naturalistic actions, moral judgments, etc. And you can, tell people to think about the thoughts or not, in which case activity would be spontaneous. You can actually have words that, like think and know and believe in these stimuli or not, so that the person is just inferring these mental states from the stimuli. A wide variety of stimuli have been used, and they all converge on a result that the right TPJ gets activated when thinking about other thoughts. So to review, we get right TPJ activity high when thinking about true or false beliefs, but not for these other aspects of people, right? So not for physical appearance or personality, personal history, preferences, feelings, unless, like in the eye study, you were prompted to mentalize about somebody's feelings. And notice, though, that these types of things would activate the medial prefrontal cortex, but the right temporal cortex requires that the stimuli have something about another's thoughts. So the right temporal parietal is more active for mental states than physical states, or other socially relevant physical traits, or internal bodily sensations, or even the consequences of an action. Sachs sort of summarizes a series of observations here by saying metabolic measures of activity reliably increase when the participant is thinking about thoughts, right, across a wide range of stimuli and tasks, but not in response to a variety of similar controlled tasks and stimuli. Right temporal parietal junction activity is correlated with behavioral measures of thinking about thoughts, like we saw in the social animation study. And in fact, Sachs, in her TED Talk on moral judgment, will have further evidence of this correlation. And again, in her TED Talk on moral judgment, she'll show us that disrupting activity in the right temporal parietal junction using transcranial magnetic stimulation, it can lead to deficits in thinking about thoughts. So we'll see that disrupting activity in the right TPJ will influence people's moral judgments because, she argues, it's interfering with the subject's ability to process thoughts of another person. Okay, finally then, you'll recall that 3-year-olds do not pass the false belief task, whereas 5-year-olds do. And that suggests that perhaps some kind of brain maturation is going on there. Maybe these mentalizing systems come online, and that's why the 5-year-olds are able to process somebody else's thoughts or a false belief, and a 3-year-old can't. So researchers were interested in monitoring any kind of developmental change in the brain that is correlated to behavior. But it's difficult to put a 3-year-old in the fMRI scanner. Nevertheless, they have put children as young as 5 years old in the scanner. So I wanted to show you some data. So here's a slide looking at brain activity in adults for the basic contrast between stories with mental content, so people are thinking things, having thoughts, versus some story about a physical happening. And sure enough, you get right TPJ activity. same pattern of activity in younger children, 6 to 12. Now remember, this is after the age of 5, right? So we know that they can pass the false belief task, and sure enough, they have a similar pattern of activity for this contrast, mental versus physical. But the story gets a little more interesting when we consider adding a different set of stories, a social set of stories. So here in this study, what they'll do is they'll put 5-year-olds and 8-year-olds and 12-year-olds and adults into the scanner, and they're going to hear one of 3 types of stories. They're going to hear the stories, not read them. It's easier for the 5-year-old to hear the story than read it. So some stories they'll hear are about people having thoughts and beliefs and about mental states. Other stories are about people, but not about their mental states, so what they look like, for example. And then stories about just physical things in the world. And again, we're going to just sort of look at the response of the right temporal parietal junction as the subjects are hearing these stories. So let's take a look at the adults. Like we've seen before, when you hear the stories involving mental states, you get increased activation in the right temporal parietal junction. You don't for the social stories or the physical stories. But look at the 8 to 12-year-olds. Yes, right TPJ is highly active for the mental stories, but a little bit of activity there, right, for the social stories. So these are stories about people, but not involving mental states. And look at the 5 to 8-year-olds. It's as if the right temporal parietal junction down here in the 5-year-olds and 6-year-olds and 7-year-olds is not distinguishing between stories about people and stories about their mental states. So although the 5-year-olds can pass the false belief task, the fMRI data suggests that these regions of the brain, the right temporal parietal junction, for instance, is continuing to undergo developmental changes. So early on, that region responds to a broader category of social stimuli, just any facts about people as well as their mental states, whereas over time, that brain region becomes more specific for processing just the mental states of other people. So this idea that a brain region shows less selectivity early on and then as development proceeds becomes more selective, this kind of change may be happening in many parts of the brain. So as input-output connections are changing, as our brains mature and we experience more stimuli, our brains are literally sort of wiring up in different ways so that now the right TPJ as an adult responds only to mental stories and not to stories about people unless there are mental states involved. But the younger brain did not make that distinction. So both people and mental states will activate that area of the brain. And this may be common for lots of different brain systems, that there's a developmental progression, and over time, regions of the brain become more functionally specialized to process certain kinds of information.